In this video we are going to look at a setup with this circuit. So I have the MOSFET switching, but like in the James Corum video, where you would like the discharge of the high inductance into the low inductance, that the energy is kept inside so that it is not used over here. I added this diode over here, so I block the circuit, so when it's running, when this contact is made, then we have a closed loop in the high induction, but when it's open, what comes back cannot come to this diode, so we don't have a closed loop. And then we can see that we have that ringing over there, where the amplitude goes up at first and then go down, and then we have other spikes further away. But what is very interesting in this is that, and I'm going to zoom a little bit in, watch what happens when I change the distance between those two coils. A little bit higher. Can you see the grow in amplitude over there? Now I have not succeeded in placing them on top of each other because then I make a shortcut, but as you already see, it is very important that those two are very close together, because when I move further away, then we got this, and when we come closer we have this, so that we see that the amplitude is very based on the distance between the two. Now when I go higher in frequency, so I am now at 3.2 kilohertz is this one, and 25% duty cycle. When I go higher in frequency, and I will go in steps of 0.1 kilohertz, so 3.3, 3.4, 5, 7, 8, 9, 4 kilohertz, 4.1, so as we could see, the nicest was around 3.8 and a duty cycle of 25%. When we zoom out, we get this one. The frequency between here is 476.2 kilohertz between those 2 points. .8, 3.7. This is 3.2. I'm going to measure what frequency we have done. Oh, it's too fast. 532 kilohertz. So that frequency is also dependent on the frequency that we put in. .1 kilohertz, 3. 2.4, 2.3, 2.2, 2.1, so 2.1. What happens when we change the duty cycle? No, the 25% is the best. Going back to change frequency. .6. Now I'm going to measure again. Can I get it stable? I'm going to use a single. It's easier to measure then. So now we are at 675.9 kilohertz, so 658 kilohertz approximately. And we put in 1.6 kilohertz. So the lower frequency we put in, the higher the frequency over here of the ringing. Going back to 3.2. Falling edge. So going to do more experiments, but this one I found really interesting. So I've placed them further apart. I'm going to change the frequency. If we can see if we get the same result at another frequency, but you can see that it's not the case. In this case we're giving lower, so when we have the right frequency we get a better result when they are close. And it's not really because changing capacitance between the two that the frequency changes a little bit, because if I change the frequency you can see that we don't get the same result again. So thank you for watching and hope to see you in the next video.